question 17, using the true moment arm method. Similar to before where we use the components of a force method, we're going to find the value of M, our mass pulling down here. Now with our true moment arm method, what we're trying to find is the equivalent moment arm, accounting for the fact that it's not, the force is not applied at right angles to these arms here. So what we're going to do instead is we're going to find the moment arm that is at right angles to the forces. What that means we can do is if we draw this line through here, you can actually see that now becomes a right angle with our force M. We can draw a little there. And if we do the same over here, we can draw our triangle over there. If you notice, we have those two triangles, and what we want to find is the perpendicular length from A to this line here, and from this point here to point C. Oh, no, from this point here to this intersecting point there, and A to the line there. How we can do this is by using trigonometry. And as you can see, we have an angle here, we have a right angle triangle, we have a length, and we have the unknown adjacent length we want to find there, and the unknown adjacent length we want to find over here. So if I bring these triangles over here, so this is 30 degrees, we have A, we have our horizontal being 350, or hypotenuse, sorry, and we want to find A. So SOHCAHTOA, so we want to find our adjacent, so we know it's 350 cos 30 degrees. That should be the length for A. And for our other triangle, we have this. We have 30 degrees here. We have our adjacent length that we want to find. We have our hypotenuse length of 900. And therefore, again, it's adjacent over hypotenuse. So 900 cos 30 degrees. So we have our new true moment arms, which means that we have to now just use the same method as before. Sum the moments about B, we'll use this as the positive again, is equal to 0. So 0 equals, well, first one was 20 kilonewtons, 20, multiplied by 350 cos 30 degrees, minus M times 900 cos 30 degrees. If you've watched the previous video, you'll know that this is going to end up being the same answer. So if we replace that, bring the M over to the other side, and then divide the right-hand side by these values here. So 700 cos 30 degrees over 900 cos 30 degrees, and therefore we get 7.78 kilonewtons. Obviously, we need to find the mass, so we simply divide by the acceleration due to gravity, because F equals mass times acceleration. So we simply divide by the acceleration, and our mass becomes equals 778 kilograms on the assumption, assuming G equals 10 meters per second squared. So I think this way is probably a bit faster and a bit easier. It's easier to draw those triangles. Key to realize is that we're trying to find the equivalent right angle moment arm. So that's where we have this right angled length, and then we can consider that this force is now applied at a right angle to that. So we take the entire force, but we only take a portion of the moment arm. Whereas before, we were taking a portion of the force, but the entire moment arm. So that's the two different ways to think about this style of question.